Join us as we dive into our obsession with true crime, history, and mysterious stories. Each Corrupted Clip episode is less than 30 minutes long, providing you with the perfect bite-sized content to get you through the day.
We assume no responsibility or liability for any errors or omissions in the content of this episode. The Corrupt Podcast is based on the facts and our opinions of the case. Listener discretion is advised.
Welcome to the Corrupt Podcast.
A 124 light-years from Earth is the exoplanet K2-18b. Larger than Earth but smaller than Neptune, this planet might hold the strongest possibility yet of life outside of our solar system.
Head on over to patreon.com/corruptpodcast to join the Corrupt crew. We love True Crime Tuesday. Unless you are a conspirator and corrupted tier member, you get day early access to episodes dropping on a Monday. Shout out behind the scenes content, water bottle stickers, and exclusive episodes can all be found over on our Patreon. The link is in the episode notes as well. Discovered in 2015 by the Kepler spacecraft, the planet K2-18b has fascinated astronomers with the possibility of extraterrestrial life. K2-18b is an exoplanet, a planet that orbits another star outside of our solar system. It's considered a super-Earth, as 2.6 times the size and the mass of 8.92 Earths. The surface of K2-18b is debatable, listed as both potentially rocky or ocean-covered.
Or maybe it's both, like Earth. K2-18b is too far away to see with the naked eye or most telescopes. If we could see it, though, it would be part of the Leo constellation. K2-18b orbits a smaller, cooler star than our Sun. This star is called K2-18. Closest to the star is the planet K2-18c. 18c was discovered in 2017 and is described as Neptune-like and doesn't have the same potential for life as 18b. To summarize, you have K2-18 the star, K2-18c the closest planet to the star, and K2-18b that is orbiting farther from the star. Earth orbits the Sun in 365.25 days. But K2-18b has an orbital period of just 32.9 days.
That's a fast orbit.
Yep.
I guess it's a smaller sun.
It is smaller.
So that makes sense. K2-18b is in the habitable zone, or Goldilocks zone, from its star. According to NASA, this means it's not too hot and not too cold for liquid water.
Keeping it simple, NASA. I dig it.
Like our solar system, the inner rocky planets, Mercury, Venus, Mars, and the outer gas giants, Jupiter, Saturn, Uranus, and Neptune, are not in the habitable zone. Only Earth is in the habitable zone of our solar system.
Venus may have had oceans, but they evaporated due to the intense heat. In 2013, evidence of an underground lake was found on Mars. Based on the minerals, scientists believe that the lake was liquid water at one time, but now Mars is a large, frozen planet after losing its atmosphere.
That's amazing to think of.
It really is. There are 1,780 confirmed planets outside of our solar system. Of those 1,780, only 16 planets are in the habitable zone and have a similar size to Earth. The habitable zone has the perfect temperature for life, but the planet size is just as important. This is because a smaller planet might not have an atmosphere. On the other hand, a larger planet may have a higher atmospheric pressure and extreme weather.
Okay, I gotta unpack this a little bit. So, a habitable zone considered to us, what is that compared to? Like, how do we compare the certain kinds of life into a habitable zone? Like, for instance, if there were extraterrestrials, how do we know how aliens can live? Like, it's compared to a habitable zone to us because, like, we breathe air and whatnot and life, but compared to an alien, it might be different because they might not breathe air.
Right. They could have gills.
Right.
So from NASA's point of view, with the habitable zone, they're really looking to see if it's too hot, like Venus, where the oceans would evaporate, or is it too cold? You know, is it too far away from its sun? It's too cold, so there would be no water. So we're looking for that Goldilocks zone. Once they find that, like that's their main, they're narrowing it down, right? Like we had 1,780 planets. Now we're down to 16. Well, of those 16, we want them to be similar size to Earth because we're basing this on our life on Earth. What it would take for a human to survive initially.
Okay.
I think you're correct of like, what if it's a water planet and they have gills or they, you know, they don't need the same oxygen levels that we need. You know, we need trees. Do they have trees? At this point, the information with K2-18b is so very limited that we're not talking about aliens walking around on a planet. We're talking about, could bacteria grow? Like tiny molecules. The sky's the limit here. Like real, I mean, we're in space, like anything.
Literally.
Galaxy is the limit.
Yes. K2-18b is 124 light years from Earth. If you drive a car at 60 miles per hour, it would take 1 billion years to travel from Earth to K2-18b. An airplane at 600 miles per hour would still take 139 million years to make the trip. Finally, even at light speed, going 671 million miles per hour, it would be 124 years before reaching K2-18b.
K2-18b made waves in 2023 when NASA's James Webb Space Telescope made a discovery of carbon-bearing molecules, including methane and carbon dioxide in the atmosphere. The findings of significant amounts of methane and carbon dioxide and a lack of ammonia was a huge breakthrough because it could prove that K2-18b has an ocean. Combined with the habitable zone, this could even prove that the planet has a deep liquid ocean. The process of looking at K2-18b's atmosphere wasn't as easy as just looking through the telescope, however. The planet provided more of a challenge because it was outshone by the glare of its sun. So scientists got creative and used the light from the K2-18 star to their advantage. As K2-18b passed in front of its star, a very small amount of light passed through the atmosphere and then reached the James Webb Space Telescope. This is how K2-18b was determined to have carbon dioxide and methane with minimal ammonia. But it's just the tip of the iceberg for the scientists.
With the information of a possible liquid ocean, the planet was pushed into popularity as a Haitian world. This means that K2-18b is larger than Earth, smaller than Neptune, with thick hydrogen-rich atmospheres and liquid oceans. Scientists are looking for rocky planets like Earth, but the possibility of life on a Haitian world exists.
Think of it as a planet that is made up of mostly oceans, all of the life forms that could live on a water planet.
Like Aquaman.
There you go. People with gills. They're not walking on two legs. They're swimming in this deep ocean.
Can you explain what a liquid ocean exactly means? Does it mean what it sounds like?
Just like Earth.
It's just an ocean that's liquid?
Yep. If the atmosphere findings are correct, because at this point there's still a shadow of a doubt, which to scientists, there can be no doubt, and we'll talk about that a little bit later, how specific they are before they determine that it's a fact. But if this finding is correct, and if K2-18b is an ocean planet, it would be like Earth, except no rocky land, no North America, South America, Europe, right? Like no continents. It would be water.
Okay.
So very similar to Earth. Again, it's too far away to see. So maybe there is land. Maybe there's islands. Right? Like you could have Hawaii out in the middle of an island. We don't know. So we can't see in yet.
I just got caught up on the liquid ocean part. And I was like, well, don't we just call it an ocean?
Well, but Mars has a frozen lake. I think that's where they're drawing the line, though, is that, this is a frozen lake. That had a lake that evaporated. This would still be liquid, which is what makes this so amazing. It's in that habitable zone, so this is liquid, just like us. Maybe not salt water.
Okay. So it's kind of taken it the scientific route.
Right.
Like, we don't know. We only know so much. We do know it's a liquid ocean, and they're saying liquid because it's not too hot and not too cold. Mm-hmm. It's
the Goldilocks
still
zone.
Liquid. It's not. Yeah. Okay. I gotcha. I'm on the same planet. Don't you worry.
I really just want to call it K2SO from Star Wars.
Oh, yeah. Yeah.
K2-18b is just so close. Can we just call it a droid?
Do you think that's why they named it that way?
No. It stands for something specific. Like, it was the second one that the Kepler something or other saw, and then A, B, and C. Like, the star is just K2-18, and then they numbered them out. But the numbering doesn't make sense because they started with C in the middle, and then B is farther away. So how does that make sense?
Nope.
Shouldn't it have been A, B? Where's A?
Yeah.
Yeah, see? I was like, why is this C and this is B? And where's A? I had questions. I still don't know.
You know, I have questions about why there isn't any B batteries.
There's no such thing as a B battery?
There's no such
There's
thing.
C and D. There's A.
There's no such thing as a B battery. Why is that? Can we talk about that? Can we have a whole episode on that?
Absolutely. Put it on the episode list. I didn't know that B was missing. Justice for B.
This is this type of shit I think about on a daily basis.
If K2-18b is an ocean planet, it may still be uninhabitable, as their ocean floor could have ice to the planet's core, whereas Earth has a seafloor. K2-18b's larger size might support the theory that the core is ice. It has a radius 2.6 times the size of Earth and may contain a layer of high-pressure ice. On the other side, K2-18b is close enough to its star that it might not be an ice planet at all and have liquid water instead. There is a third theory that the ocean is made up of magma. It's all speculation until further research is completed and released to the public.
In April 2025, K2-18b was back in the news. Using the same technique as 2023 scientists tracked how light reached the James Webb Telescope after being absorbed into gases surrounding K2-18b. This time the team used a different telescope instrument, a MIRI, or MIRI, Mid-Infrared Instrument Spectrograph. This was more equipped for the task.
Scientists found dimethyl sulfide, DMS, and dimethyl disulfide, DMDS, or possibly both gases, in K2-18b's atmosphere. On Earth, dimethyl sulfide, DMS, is mainly released into the atmosphere from certain plants and marine microbes as they break down. Traces of DMS was found in 2023, but was removed from the research as they felt there wasn't enough evidence to prove that the gas was in the atmosphere. Now it's back, and this time with a much more significant amount.
DMS and DMDS are molecules from the same family. The amount of DMS and DMDS are shockingly high compared to Earth, though. On Earth, it's below 1 part per billion by volume. On K2-18b, the molecules are estimated to be 10 parts per million. This is thousands of times stronger than the molecules of Earth's atmosphere. The large amount of DMS could potentially make for a smelly atmosphere and would smell like sulfur if you were on the planet. K2-18b has very minimal oxygen, so we wouldn't be able to breathe to smell that sulfur.
At a press briefing, Niku Madhusudan, a University of Cambridge Institute researcher, said,
"These are the first hints we are seeing of an alien world that is possibly inhabited. This is a revolutionary moment."
Findings of DMS does seem to back up the statement about life on K2-18b, as the DMS is only known to exist from plants and marine microbes on Earth.
Other scientists are not so sure about alien life on K2-18b. The data is too inconclusive for them to truly believe life exists on K2-18b. Niku's research paper states,
The spectrum also suggests potential signs of dimethyl sulfide.
with other scientists pointing out that suggests potential does not mean there is life on K2-18b, or even that it is habitable. Scientists worry that the idea of life outside of Earth is so thrilling that we're seeing what we want to see in the data.
MIT planetary scientist Sarah Seeger told Astronomy,
"With thousands of exoplanets in view, the temptation to overinterpret is strong, and some are jumping the gun. When it comes to K2-18b, enthusiasm is outpacing evidence."
The Sigma standard is a way for scientists to determine if the data could be a fluke. The chance of K2-18b's atmosphere containing DMS is a 3 sigma, meaning there is a 99.7% chance, which sounds great, but to an astronomer, that's still a 0.3% chance of something random. The golden ticket here is DMS to be confirmed as a 5 sigma. It can't be considered as true until we know that there is a 99.9994% chance as a 5 sigma discovery.
NASA is working on a new space telescope, the Habitable Worlds Observatory, with the intention to detect life on Earth-like planets. This telescope is an infrared optical ultraviolet space telescope for the sole purpose of looking for signs of life on other planets orbiting other stars. The launch for the Habitable Worlds Observatory is still many years away, possibly in the 2040s.
Even if scientists confirm extraterrestrial life on K2-18b, the planet is simply too far away for us to visit. At 124 light-years, we would need an even faster form of transportation. Hopefully someday soon we'll have more information on K2-18b. Check back. We'll share updates as we have more information. We would love for you to become part of the Corrupt Crew. You can find us on Patreon with multiple tiers and PayPal. This will score you our appreciation and will announce your name in a future episode. Both links are in the episode notes. Case suggestions and feedback can be emailed to us at corruptpod@gmail.com.
The sources for this episode would be listed in the episode notes. You can find us on Instagram, Facebook, and Threads. Don't forget to subscribe to catch our new Corrupt content. Please also leave us a review wherever you're listening to this episode. Bye!
Bye!